Really exciting afternoon session for you here, ladies and gentlemen. This next gentleman is going to talk on the concept of the data breach pipeline. There are a few people better qualified in the world to do so. He knows so much about the subject. He's testified before US Congress on the impact of data breaches on knowledge-based authentication. I think I probably only had to watch that footage of Mark Zuckerberg being grilled by the US Congress to think those guys really know what they're talking about. That must have been a tough day at the office for this guy, who is the founder of the data breach monitoring and notification service, Have I Been Pwned? We all know the site. That's the site that millions of people have gone to when they've received that email suggesting they've been watched doing that sort of stuff. You race off to this website and hypothetically, I've been told, suddenly feel a lot better about yourself and your ongoing employment prospects and relationship with family members. Anyway, let's give him a big round of applause. He's on stage. Troy Hunt's here, ladies and gentlemen. Troy, this is all yours. The data breach pipeline.
Cheers, mate. Oh, that was a nice intro. Thank you. So normally I'd sort of start off by saying, does anyone know this website? But there's probably not much point now. Who has used this out of interest? Wow, okay. I got stickers for all of you too, if you want to come and get them later on. So just as a recap, Have I Been Pwned is a data breach notification service when we have large data breaches, Dropbox, LinkedIn, Ashley Madison, stuff like that. Data gets spread out all the way around the world. I aggregate it, load it into that system, and you can go and figure out where you've been exposed. Companies can go and do things like domain searches, figure out who in the organisation has, say, a Dropbox account. It's kind of interesting for a lot of companies. And the interesting thing about this service is it started off as something very little back in 2013. So this was like the first tweet ever. And I thought, this will be good, like a few of my mates will use it, it'll be interesting. Not everyone thought it was always going to be a good idea. They thought I was going to be like running a spam harvesting site. But the funny thing about it is like Adam said, it kind of took on a bit of a life of its own and became something much bigger, to the point where it ended me up over here. And, you know, like he made it sound very serious, and it was kind of serious. I had to get dressed up. Everything you see me wearing there, I had to buy. So I'm dressed up for today, because I live on the Gold Coast, but I had to put clothes, shoes on and things like that. And I kind of didn't want to make it too serious either. Like it's a big event, but, you know, let's have some fun. And I thought, I should get some cool socks. And I actually tweeted out, I said, has anyone got some nice socks they want to send me? So Sophos sent me these socks. It says, for those about to code, we salute you. And I thought, that'll be a bit of fun and it'll just, you know, lighten the mood a bit. And it turns out that the socks were quite popular, and you can even now go and buy a stock photo of my socks. $199 off Shutterstock. And the sort of thing that struck me the other day is like, how did this like little project somehow end me up in Congress with people taking photos and selling my socks? So, several years on, the thing keeps growing and growing because we do have so many different data breaches happening pretty much every day. Like every day I look at my Twitter feed, there's a bunch of people saying, hey, CC Troy Hunt, have you seen, for example, today, it's Flipboard. Everyone's getting Flipboard notifications. It was Canva a couple of days ago. There's always something. I thought it'd be interesting to sort of have a look at who is behind a lot of these breaches as well, because I think there's a perception which is often really different to the reality. And I'll give you a good example of this. So this is TalkTalk. Now TalkTalk is a massive UK telco, and they had a breach in 2015 that they said cost them £77 million. Like a massive, massive amount of money. Now at the time when they had the incident, there was a detective who came out and he was quoted as saying, we think it is Russian Islamic cyber jihadis. This is a true statement. And it just kind of feels like he just picked scary words and put them all on the page. And as best I know, it is none of these things other than maybe cyber, which, let's face it, is a little bit generic. So it turns out it was actually this guy. And he's leaving court here after having to answer for his actions. You can't see his face because it's a 17-year-old child. £77 million of damage, 17-year-old child. Now, he was actually 16 when he broke into TalkTalk using SQL Map, freely available SQL injection software. Did the £77 million worth of damage. The lawmakers there took it quite seriously. They took his iPhone away, which, in fairness, for a 17-year-old is probably like hell, right? But the thing that strikes me is how often it is like children who are breaking into these systems, even great big multinationals. And that the thing about kids and hacking these days is they have access to so much material to be able to do this. And I want to give you an example. I went over to YouTube and I thought, look, I'll pull a video that demonstrates hacking, and there's a gazillion of them on YouTube. I thought I'll pull one which is probably shows how simplistic the threat actor, for want of a better term, is. Have a quick listen to this guy.
Let's do a professional video. Let's actually show you how the concept works. And I'm using the SQL or SQL method here, SQL injection.
It's not just me, right? It's this. And I don't know if it's a squirrel or a chipmunk, but I know it's not a sequel. So you've got kids creating videos about how to break into systems. You're going to see what he does next in a moment. And they literally can't even pronounce SQL. So anyway, he starts doing this tutorial and he goes off and he does this Google Doc and he wants to find websites that have a query string parameter in them that he can then take and put into automated software. So he ends up on this site here, and this is a gold bullion trading site. So have a look at what he does once he gets over here.
Okay, so with this extension, what we do is put a little apostrophe here, little comma-ish. Put it there, press enter, and there we go. So this means that we have an error in the database. So there's an error in their database. And their database is MySQL server. There you go. So because it's MySQL or MySQL, we can target it and grab all their info.
Now, one thing to think about here as well is what do you think it's like for kids sitting at home watching this stuff? Right? Like, they don't have that moral compass yet of what it means to do what he's beginning to do, because he's just started parameter tampering. He's put an apostrophe in there. Somewhere in the application, they're concatenating whatever that query string value is into a SQL query. Obviously not doing any sanitization, parameterization. He's established a proof. He grabs the URL, goes and throws in a Havage. Free SQL injection software, shows you how to pull out all the email addresses, all the passwords, and then he logs into the site with them. Now, like, I was watching this and going, it's one thing to do this, it's another thing to video yourself doing it and put it on YouTube as a tutorial for other people. So once he's authenticated, he can pull out banking data. And this is a child whose voice is probably just breaking, can't yet pronounce SQL. It's just too easy. So one of the things that I think the industry's starting to focus on a little bit more is, how do we tackle this? Like, how do we start to think about getting kids on the right pathway? And the NCA in the UK is starting to focus on this quite a bit as well. So I want to show you just a little short clip here. They've got this advertisement of how they're trying to reach parents. It's a little bit of fun, but have a think about how representative this is of most parents out there whose kids hacking away in their bedroom and the parents have got absolutely no idea what they're doing.
Ollie's such a clever boy.
Such a clever boy. Custard cream.
Spends all night on his computer. Listen, how smart is this? You know them shooter games? The other day he was losing, so he crashed the server. Proper whiz kid.
It's amazing what kids can do these days. Night, Ollie. Or what do they call it? DDoSing. That's it, I saw it on the telly.
And he's no dosser though, our Ollie. 100% in maths. Every single exam for the last 2 years. Not to mention his GCSE coursework.
He's going to go a long way.
Down the M11 to Cambridge. Computer sciences degree.
Top career in computing. Internet billionaire by the time he's 25. The next Steve Gates. You know, he's very clever with his money too. He's got more in his account than me. Chocolate finger.
We only give him a tenner a week. Told us he robbed a bank.
And the thing is, like, it's very close to the truth, right? Most parents have got no idea about the technology that their kids are using. And then the kids don't yet have that moral compass, and we end up with things like what we saw just before. Now, of course, a lot of these breaches impact passwords. We saw passwords on the previous screen. He used them to then go and authenticate to the app. So I thought it'd be worthwhile just recapping on passwords briefly in terms of where we've come from and where we're going as well, because there's a lot that is actually changing. And on that first bit, the bit where we've come from, this is MIT in the 60s, and this is believed to be the first ever case of having a password on a computer system. So this was their compatible time-sharing system. You'd go into this room of computer and you'd log in, and then you would have access to whatever it is you did with the computer that filled up a room back in the 60s. Now, if we think about the threats we had then and the threat actors and the access that they needed, first of all, they had to have physical access. You had to be in the room. This was not a connected system. You couldn't go home and dial in. When you got in there, you needed sophisticated knowledge. I don't know what you do when you get in there. Maybe you take Mikko's punch card from this morning and put it in or something. Who knows? But you've got to know what you're doing, which is really different to today. There was no password reuse because it was the first system that had a password, so there's that problem gone. And you could use basic passwords because your risk surface was so small. But the way passwords worked back then, the first time ever, is still pretty much the same as they work today. You've got two strings in your head. One's a username, one's your password. If the ones in your head match the ones in your system, you get to log in, job done. But the 60s is very, very different to today, yet the same mechanism is how pretty much every system we use today works. So that was the 60s. Now we move forward, go forward a couple of decades, get to the 80s. We start getting connected systems. So this was a Prestel, and Prestel was used by about 90,000 people. You'd plug this computer into your TV, because we didn't have computer monitors in the home at the time. You'd plug it into a modem and you'd dial in. Once you dialed in, you'd authenticate. There's a little BBC clip which shows how to log in to the Prestel.
The Prestel computer is now asking me to enter my own personal password, which I've now done.
Everyone get that? Let's zoom in hand, see what's going on. Right, like 1, 2, 3, 4. So what we're sort of seeing here is humans taking the path of least resistance. It's like, oh, something's in my way. How quickly can I get around this thing? Not much quicker than 1, 2, 3, 4. I assume the minimum length of the password was 4, otherwise it would have been 1, 2, 3 or something like that. So this is now more problematic than MIT in the 60s because it's a connected system. You've got people remote. You've got more people with enough knowledge to use the system compared to the 60s. We go forward another couple of decades, get to internet era, get to the 90s. We've got millions of websites, billions of people using them. And people are using bad passwords like in the Prestel. So we said, all right, we're going to fix this. The way we're going to fix this is we're going to create password complexity rules. Now, we've got a bit of file footage of Bob here. Now, Bob's trying to create an account on a website, and the website says to keep your password secure, it must have at least one lowercase character, at least one uppercase character. It's got to have a number. It's got to have a non-alphanumeric character. It's got to be at least 8 characters long. You can't have used it in any of the last 3 passwords. And now Bob is losing his mind because he can't create a password. And we have all been there, right? It is painful. So what do? We create passwords like this. And this is a good password. Crickets. Okay. It is a good password by the mathematical definition of what most people think makes a good password. Because think it through, right? You've got uppercase, lowercase, number, non-alphanumeric. That's actually 15 characters long too. Yet we look at this as humans and we recognise patterns and we think, well, no, maybe there's more to password strength than just mathematics. Yet still, it meets that basic criteria. And any one of you could go back to your places of work on Monday and create this password at the office. Now, if you did that, what is going to happen 90 days from now? Got to rotate it, right? What are you going to do 90 days from now? You're going to put a 1 on the end. And the funny thing is, every time I do this talk, there's always everyone just going, yeah, you just put a 1 on the end, because you all do it. I know you do it. I've seen your passwords. So we do this, and again, it's humans circumventing the controls that get put in place. We know this. The hackers know this. Like, I hate to break it to you, they have worked this stuff out. And time goes by and we just keep incrementing the number because this thing is in our way. And there's a fun trick you can do. So take the number that's at the end of your password right now, divide it by 4, that's how long you've been at the company. Works, doesn't it? So this is all very, very predictable. We know what's happening. But what happens is when we enforce arbitrary complexity rules and we force rotation, people take shortcuts. They do things to try and remember what the password was, which actually weakens it. I'll give you a perfect example of this. Remember last year in Hawaii, that emergency response system went off and everyone thought, oh, we're going to get bombed because their phones started getting all the messages. They went and interviewed this guy afterwards, and he's here in this emergency response centre, and they're kind of interviewing me, like what happened, why did the thing go off, were there really any bombs? And he's standing in front of the screens there, and there's something alarming down here. They're still using Internet Explorer. And he's got his password pasted on the screen. And this is what happens. And again, it's people trying to find the shortcuts around the controls that are standing between them and doing the thing that they're there to do in the first place. So this is changing. And here's where it gets sort of interesting. There's a couple of really interesting things that are starting to come out from industry bodies about how we should do this differently. And the first one I thought we'd touch on is from NIST. So NIST came out a couple of years ago and said, we should not impose composition rules for memorised secrets. So verifiers, applications, shouldn't say uppercase, lowercase, alphanumeric, because it's such a predictable result. Yeah, you think about it. If you went and tried to just use a lowercase password and it says, no, you've got to have an uppercase as well. Yeah, okay, so you uppercase the first character. Got to have a number as well. You put a 1 on the end. Got to have a non-alphanumeric character. You put an exclamation mark on the end. It is so predictable, time and time and time again. Stop requiring this because people take shortcuts, make things worse. The NCSC in the UK, around a similar time, said you should only ask users to change their passwords on indication of suspicion of compromise. Unless you think the password has been compromised, stop forcing people to rotate it. Now, they don't just say get rid of stuff either. They say, look, stop doing that, but there are other things that we can do now that we couldn't do before. We have almost ubiquitous 2FA. We've got things like U2F tokens. We've got user behavioural analytics. We can see deviations from the norm. We've also got more encrypted networks than ever as well. So the exposure of passwords is different to what it was, say, even just 10 years ago, let alone 20 years. So this is how passwords are evolving and how we need to start thinking differently about them. And over time, these will start to filter through more. Microsoft just recently updated a bunch of their baseline guidance for Windows Server and for desktop PCs. Said, look, we're going to remove the rotation requirement. Things are progressing. Now, also on the subject of passwords, we're seeing huge exposures of them in numbers that we've never seen before. This was in January, and there emerged what was referred to as Collection 1. And Collection 1 was a list of usernames and password pairs, often referred to as a credential stuffing list. Someone sent this data to me, and turned out there were 773 million email addresses in there. There were more than 1 billion passwords because many email addresses had more than one password. And this was an amalgamation of different breaches from different services. I was in there, including a password I'd used in the past. And people take these lists and then exploit the victims. Wired picked it up, CNET picked it up, 21 million unique passwords. Also, do the maths. 773 million emails, but only 21 million unique passwords. What did that tell you? Not so good with the passwords. Fortune. I always find the Fortune stuff interesting because now it's like consumer, mainstream media. This is not just technical people anymore. It's the sort of thing my parents would read. Here's how to find out if your email address was one of them. They sent people to have I been pwned. I got 10 million people come to the site in a day. That was fun. I don't think I've recovered quite yet. Now, often you see this sort of stuff and a combination of the press and I think a lot of the masses, they go, oh, must have been on the dark web, because I keep hearing about the dark web. The dark web sounds very scary. This is where the criminals go and they distribute the data and they sell the drugs and everything. Now, a lot of this is on the dark web. It's also on Twitter. And this is the reality of it. Most of the time, when people send me data, it's floating around the clear web. I know it doesn't sound as scary, and I'm so sorry for the vendors who are trying to sell stuff just based on what's on the dark web, but a lot of it is just floating around in the clear. So this, as you can see, is collections 1 through 5. I had collection 1, 773 million unique email addresses. That was about 8% of all the collections combined. So this floated around Twitter. It's on mega.nz. A lot of the data I see gets redistributed on Mega because it's a good file sharing service. Raises a question though, what do people do with this, right? So imagine you've got, let's say round numbers, you've got 1 billion email address password combinations. What do you then do with them? I went and pulled a bit of a clip. Here's another tutorial about how to abuse credential pairs. So what we're going to see is how to mount a credential stuffing attack.
Hey yo, what is going on guys, with this and welcome back to a brand new video here on the channel. Now in this video, I'm going to be showing you guys a checker I've made for Spotify accounts. You can check if the accounts are valid.
Now Spotify really frequently features as the target of credential stuffing attacks. I get emails from people all the time. They go, hey, do you see Spotify's had a data breach? Because a whole bunch of credentials have appeared on Pastebin. Now this is not generally what has happened. And we're going to see, as this guy goes through the process, how Spotify has a, air quotes, data breach. So let's have a look at the checker he's made.
But before we start, I just want to say that this is for educational purposes only, and this is obviously not made for checking cracked accounts, if you guys know what I mean. This is for checking your own accounts if you guys got multiple, so you guys don't have to check one by one, and this will make it a lot easier.
All right, so let's just be clear about this. You have so many Spotify accounts, you can't remember which ones work anymore, so you need this script to go and check your credentials. Keep this in mind.
It will also tell you guys if the account is a Spotify Premium, Spotify Family, or a Spotify Student, whatever.
You have so many, you also can't remember what type of account you created. But you'd like to know. It would be nice if there was a tool to help you establish this.
But before you open this actual program up, you're going to make sure you have combos.
All right, now this is where we start to get to the pointy end of it. So combos are username, password combinations. And we're seeing like one tiny little bit of a snapshot of what a credential stuffing list looks like. Email address, password, over and over again, 1 billion times. So let's have a look at what he does with the combo.
You're going to type in combos and then threads. Let's do 4 this time, so it goes a bit faster. So as you guys can see, already we got 8 hits. As you guys can see, it keeps getting hit because these accounts are high quality, aka HQ. As you guys can see, we keep getting hits. I don't care if you guys steal these accounts. I have about 9,000 at the moment.
All his too. It's rather miraculous, isn't it? Now, all he's done here is his script. He's gone to Spotify and he's had a look. Let's say it's the Spotify API, for example, sits behind the mobile app. He's looked at it and he said, okay, well, what's the HTTP request pattern which logs on? That's a post request to this path. There's a field called password and a field called username. I'm just going to automate that, and then I'm going to multi-thread it, and I'm going to pass in a big list, go outside and play. Bob's your uncle. Now he's got 9,000 accounts. The challenge for us and the challenge for you guys is how do you defend against that? How do you defend against a request coming to your site, legitimate username, legitimate password, but not the actual person that owns it? And this is becoming a really big problem. And there are so many tutorials like this out there. I wrote a blog post recently about the fact that most of these Spotify breaches I see are just successful credential stuffing, and I embedded a video and then it got taken offline. So I embedded another one and it got taken offline. So I embedded this one and it's still there. There's just a heap of them. They're all over YouTube. So data breaches and passwords are a massive thing. Data breaches and connected things are also becoming a massive thing. And I thought I'd touch on a few which have hit either have I been pwned or my radar in recent times. And the first one was this one. Has anyone got one of these? Thank God. Okay, so here's the value proposition. This is a cloud pet. So imagine you've got a kid in bed, you know, wanting to talk to mum because she's working late and phones are boring. So why not get them a connected teddy bear with a microphone in it and put it in their bed? I know. So anyway, this is what they were. They're basically dead now. The company's gone bankrupt. but they're connected teddy bears. They've got a little light that flashes when a message comes in, they've got a button in the paw, they've got a microphone, they've got a speaker. Now, when you record a message through this, it goes up into the magic of the cloud, and it's stored up there. Cloud Pets stored all of their data in a MongoDB, publicly facing, without a password. And then it looked like this. Your database is backed up in our servers. Send 1 Bitcoin to this address and send your IP to that email address. Now, there are about 560-odd thousand accounts in there. Someone did grab them, sent them to me for have I been pwned, but then it later got ransomed like this. Now, we know that this is what it looks like because we pulled logs out of Showdown and we can go back and actually see the state of the database at the time. We also know that 2 other people subsequently came along and changed the Bitcoin address to their own, which, okay, it is kind of, all right, you know, you don't have to do the crime, maybe you get some of the proceeds. Incidentally, no way it's backed up either. It's just been nuked. And the thing is that this happened and then the Cloud Pets came back online and nobody got told. So obviously the company knew. Continuing the IoT thread, we're seeing IoT in all sorts of places we never had it before. In cars, for example. So this is a Nissan Leaf. The Nissan Leaf has a companion app so that you can do things like pull back the battery status, it's an EV. You can pull back the trip history. You can also control features of the car. So you can turn the heating on. I was in Norway doing a workshop and we do this exercise where you take your phone, you route it through your PC, you have a look at the traffic going backwards and forwards just by naturally using an API or naturally using an app that hits APIs, and you draw certain conclusions about the security posture. And one of the blokes in my workshop had one of these cars and he was curious. He said, I wonder how my phone knows which car to turn the heater on. Because in Norway it's so cold, you've got to be able to turn the heater on before you get into it or you freeze to death or something like that. So he's like, all right, there must be some sort of API key, like maybe there's a bearer token or something stored within the app. And then when I go and turn the heater on, sends the bearer token over a secure connection, turns on my car, doesn't mess with anyone else's car. So he proxies his phone through his PC. He looks at the traffic and he discovers that the API key, so the secret that allows you to control features of a car, is printed in the windscreen of the car. They used the VIN number as the API key. Now, not only is it printed in the windscreen of a car, so you can walk around and just start taking photos of cars and going, my car, my car, my car, you can also enumerate them, because the last 5 digits, you can just keep guessing numbers and finding more cars. And this was another example of how hard it is also to get organisations to do the right thing. So after we found this, I got in touch with Nissan privately and said, look, I think you should kind of fix your cars because this isn't real good. And they said, yeah, no, we'll fix it. This is very important. And eventually they just grew a bit tired of it. They stopped answering my emails. And it took a month before I discovered that someone else had found the same vulnerability. And the way I discovered this is there was a forum where people were commenting on how terrible the mobile app is. And someone reverse engineered it and said, hey, look, all you got to do is go to this URL, replace the VIN number with yours, put that as a favourite in your browser. And then when you get up in the morning, you just go to the bookmark. Job done. Heater's on. So that had to go public because they wouldn't fix it. They decided it was important after it went public. Amazing thing. And this is one of the issues we see, organisations having trouble dealing with security incidents as well. We had an issue just locally, only a couple of months ago. Similar sort of deal. There's a company called TikTok Track, and they make a GPS tracking watch for kids. In fact, they don't actually make the watch. The watch is made by a company called Gator. They make the application layer that sits on top of it. They make the mobile app, they make the APIs. And a mate of mine in the UK, a guy from a pen testing firm called Ken Munro, Ken reached out and he said, look, we've been looking at a bunch of these watches and they're kind of as terrible as what you would expect a really cheap internet-connected device to be. And they'd found a whole bunch of problems in late 2017. In fact, they'd found so many problems that we had things like Norwegian Consumer Protection Council saying, just don't get these things. Germany banned them. They're just like, nope, destroy them. They literally said destroy them because they're also surreptitious listening devices. You'll see this in a moment. So he believed that there was a security vulnerability in these. He needed someone in Australia. So he called me. I went and got one of these. And I had to go to the website in order to purchase it. So I went to the site and then I saw there was a padlock and I felt much better. No, not really. Also noticed in that second para there, it says, we take the security of your data seriously. Now, normally when I see someone say that, it's in the breach notice, which is explaining how they just didn't. So it's not really a good leading statement in my experience. So anyway, I thought, oh, we'll go and get one anyway because this is interesting, right? Like we want to see, is this vulnerability which Ken believes is in the watch actually there? So I went and got one and I put it on my 6-year-old daughter. So this is Elle, and as you can see, it's branded Gator. It's made by Gator in China, and then TikTok Track put their app layer on top. And we started having a look at the APIs. We found an API like this. And it says, get users. This is going to pull back information about the family. And all you do is pass through an ID. Now, because Ken's a smart guy and he can count, he can hack. So all he did is change the number. Change the number, another family. Like this is the level of sophistication. These are physical devices that we're using to look after our children. So when you hit that API, response comes back, it says, here's your family. We get a whole bunch of JSON back here. Here's my email address, name. Then you can start making calls to other APIs. So you can go out and actually get yourself a child. And I know this is alarming. Why is this a post request when you're pulling back an entity? This is not right. Anyway, also you can just change the ID and pull back another family. Now, there was auth on this, and it went like this. Are you authenticated? Yes? Sweet. Go for it. It's not like, are you authenticated? Also, are you actually trying to retrieve the entity that you're authorized to retrieve? So that bit was kind of missing. And for any of you that actually test this stuff and look for it, this is like one of the most obvious things that you would look for, one of the absolute first things. Insecure direct object references, the gift that keeps giving. So you could retrieve a child. You could relocate a child. And this is where it starts to get weird because parents have these things in order to track where the kids are. So the problem there is that if you can start to relocate the child to some arbitrary location, it kind of completely destroys the whole premise of having the watch in the first place. So we tested it. We sent Elle off to tennis, just over here in Southport. And I opened up the app, and she was at tennis, and me in my helicopter parent mode, I'm like, good, I know she's safe. And then Ken dumped her in the ocean. Because he can do this, because he can put her wherever he wants, because Ken can count. Got worse than that as well. And that the bit that got worse is that these watches do take a 3G SIM card. So they can operate as a phone as well, so the parent can call the child. But it would be weird if just any person could call the child. So there's an API that lets you set who the parent is, and by now you can probably see where this is going to be going. So Ken gets hold of the API, and he said, look, we're going to make some changes. We want to give you a call. So we get Elle in her bed, and he gets one of his colleagues, Vangelis. He said, look, Vangelis, obviously you've found the vulnerability in the API. Let's see what we can do with this. So have a look at what Vangelis does.
Hi, who are you?
I am Vangelis from the other part of the world.
And when I first saw that, I was like, holy shit, this is actually feels really scary. Like, I'm okay, I was there videoing it, but it just, why is this possible? And then I remembered, well, Ken can count, and this is why we are where we are. So these vulnerabilities keep popping up again and again and again. And to their credit, TikTok Track did actually take the service down very, very quickly, but they had a lot of trouble actually understanding what went wrong and started throwing around blame and things like this. And this is one of the problems we have as well. There's so many organisations out there that just aren't equipped to deal with a data breach of any kind who don't realise that people like Ken Munro is a legitimate, straightforward guy who's only there trying to fix broken things like this. And I thought, look, we should sort of end this on a really good example of how companies are having trouble communicating. And I saw a recent case involving this. Now, this is a biometric padlock. And there's a guy called the Lockpicking Lawyer. He's got a YouTube channel where he does physical penetration testing of padlocks. It's really fascinating, actually. He gets big locks and then he's like, how can I either pick them or how much effort does it take to break them? So anyway, he's picked up this lock, this biometric lock, and he's gone, oh, look at that, there's a screw. Now, the screw does exactly what you're thinking it does, right? It's like you get your screwdriver out, you undo the screw, and the lock opens up. That's not the good bit. The good bit is he's like, okay, well, we've got to do the right thing. We've got to disclose this privately. So he gets in touch with them and says, look, I've got one of your locks. I have a screwdriver. I managed to get in there. And they replied, and they said, our locks are invincible to people who do not have a screwdriver. And this is pretty much where we are today. Thanks very much.
One quick question, if I can. Can I just ask you, that fantastic presentation, one quick question before we go, because I joked about the Zuckerberg stuff, but I've heard anecdotally that the stuff that got online about the guys asking, how do you make money out of it? Well, we run ads and all that. But in fact, I believe that testimony kept going, and there were some senators who asked some quite informed, pointed questions. What was your experience of that? Did some of those people there really know their stuff? Was it embarrassing how far off the pace they were? Can you summarise it in a generalisation, or did it vary across the people you spoke with?
So what I actually learned is when they ask questions, they're not their questions. Yeah. so they all have, and like in fairness, they're there. They were doing like testimonies on things like the opioid epidemic the day before. So they're going from like serious healthcare stuff to serious cyber stuff. So they have staffers that prepare all the questions. And the questions were actually pretty good, I thought.
I'm just going to come over here seamlessly while they set up that computer. I didn't realise they're doing that. Yeah, because so the questions were reasonably pointed. What were they trying to get at, and what do you think they came away with? What did they come away with as a benefit from the testimony that you guys provided?
So the premise was, what's the impact on knowledge-based authentication? So you know how like your bank calls up and they're like, we just want to make sure you are who you are. What's your date of birth? And you're like, oh, crap, it's that thing that's in all these data breaches. They wanted to sort of understand how that as a means of authentication really doesn't work so well anymore. So, my bit was data is all over the web. You really can't rely on this stuff anymore. And I think they got that. The trick now is to see what actually comes as a result. So this was about 18 months ago we did that.
Has anything happened yet? Where are they on? Are they moving slowly?
Well, we've still got a hell of a lot of data breaches, so it hasn't changed that. Look, I think organisations are moving slowly because we're getting better means of authentication. So stuff like U2F keys are now all over the place and lots of support for that. So we're kind of moving in that direction. But it's going to be slow because the one thing that knowledge-based authentication does really, really well is everyone has knowledge and everyone knows how to use it. It's weak, but the accessibility of it's off the charts.
Give him a big round of applause as he walks past, grabs his Zelda chess set on the way through as well. Get your daughter playing some Zelda chess. Thank you so much, Troy. What a fascinating... Just on behalf of everyone here, I want to thank you for keeping us safe from those Russian Islamic cyber jihadis. They are the worst.